bigger points. So when we look at water pollution, I think we know what it is and where it really comes from. It's people illegally dumping, not them overusing materials. You have the use of fossil fuels and runoff from those, agricultural methods that are not sustainable and cause a lot of runoff into our waterways as well. You have your two types of sources, non-point and point sources. Non-point has to do with runoff, anything that gets onto the ground and runs off into our water systems. Point source would be it being directly put into waterways, or let's say like a tanker spill would be a point source as well. Okay. When we look at, we've talked about fracking a lot. Remember, that's going after natural gas underground. And then those chemicals that are used and also some of those toxins leach their way up into our water system, and we pump them out for drinking or for using in agriculture, and then it gets into our food chain that way. Okay, we do have infectious diseases, which I told you not really to worry too much about, but all we know is that there are different types of pollutants in the water system. So you have your nitrates and phosphate systems that come from farming. You have lead, mercury, arsenic. Those are our heavy metals that can be found in the water, especially years ago when they used to just dump them directly into the water system. They're still kind of lingering, like mercury found in fish. We run into problems with lead, mostly in the piping in areas where the water system is quite old. But you can also remember that we have thermal pollution too. And that's us releasing heat into water systems, and that can kill species or cause them to move as well. Right. We looked at the oxygen sag curve. So a healthy area should have a lot of dissolved oxygen, and the biological oxygen demand would be low because there's not that many bacteria living. But if we have a point source pollutant, especially if it has fecal matter or sewage in it, you see this movement of BOD goes up, and your dissolved oxygen goes down. Okay. And then as it moves downstream, starts to become cleaner water again, so your dissolved oxygen will go back up, and your biological oxygen demand will go back down because there's less bacteria. And bacteria feed off of the oxygen, which is why you see that flip right at that point source. Okay. We do learn from our past, which is nice. We have the Clean Waterways Act. We also have the Clean Drinking Water Act that came about from a lot of problems in areas where their water was terrible. But it's good that we kind of learn from our past. But one thing to keep in mind is that every year there's a possibility that things get changed in government, and they can relax some of these restrictions that were out there, and we can see our water systems kind of have problems that they haven't had for many, many years. We've talked about fish kills, so I think we're good on that. Cultural eutrophication, remember that is human-caused, mostly human-caused, where we see an abundance of growth, let's say algal blooms, and the two leading nutrients to that is your nitrogen and your phosphorus, which mostly come from your fertilizers. How do we control eutrophication? Well, we want to stop it from happening to begin with, but sometimes that's very, very difficult. Stopping runoff from happening is difficult. So a few things that we can do. Physically, we can remove weeds. We can control the growth with pesticides and stuff like that, but we can also pump air into the water so it keeps the water moving, and it doesn't allow that film, that algal bloom, to really happen on the top of the surface. And the more we can move it and more oxygen we can keep in that water, the more healthy we can keep that water system, because the fish that rely on the oxygen will be able to continue to thrive. We can also put catch basins in, which means before it hits that water system, it hits another area where it can actually capture a lot of those toxins, or in this case, fertilizers, before they get into the water system and cause massive problems. Okay. When we look at how pollutants get into our systems, you have septic tanks that may be leaking. You can have waste lagoons that are not lined, which would be a big problem. You have landfills that are not lined. These should all be lined with synthetic barriers, and also have some clay under them too, because that would stop the movement of what we call leachate or water. You have runoff of coal mining, you have pesticides and fertilizers, all that kind of stuff getting into our water system, causing massive problems. So we have those liners, like we talked about, and one of the biggest problems that we see with it, other than like, let's say arsenic that may be in the water system due to when we dig up coal, has a lot of different chemicals in it. Other than stuff like arsenic or mercury, we can also have nitrites. These nitrogen compounds can cause massive problems with our nervous system. They can also bring on cancer-causing changes to our body, as well as hurting newborns. So let's look. So we look at ocean pollution. Most of it originates on land, and it runs off into our water systems. It runs into a river runs into the ocean, and we have these huge amounts of pollution. So if the wrong type of pollution gets into the water system, let's say fecal matter and raw sewage, that can then create a dead zone because the bacteria will feed off of it, dissolved oxygen will go down, and you will have a fish kill, and you will also have a lot of organisms that are forced to move out of that area. We have large amounts of pollution that is circulating throughout our oceans called our garbage patches. There's two really in the Pacific Ocean. There's one in the northern hemisphere, there's one in the southern hemisphere, but we also have some in the Atlantic Ocean as well. And they continue to float around. And they are huge in size, and they have a lot of waste, a lot of that originating from on land, but some of it comes from fishing vessels and it being dumped off of ships as well. Okay, oil spills, massive detriment to the ecosystem. You can see here we have the BP oil spill down in the Gulf of Mexico. You had the Exxon Valdez that broke or that ran aground and kind of leaked oil into our ocean systems, and that is detrimental to the bird population, also the fish, and that kind of works its way throughout that food chain. When we look at treatment for home, we didn't really talk about this. But some of you may have septic systems, and this is a way, if you don't have a regular sewer system, what happens is your waste comes into a chamber, and the fecal matter and sludge drops down to the bottom. You have a top layer of oils and scum that stay in the tank, and the cleaner wastewater, because there's bacteria in there that are breaking down that fecal matter and all that stuff that gets flushed down the toilet and down your sinks. The water will leach out, right, and it will go through these drains, and these drains will slowly allow that water to permeate underground, and then that will start to seep down into the ground. So it's not just below, it's not very, very close to the grass level, but it's not too deep. But all that water will make its way downward, and as it works its way through the soil, it will naturally get purified as well. A good working septic system, let's say a house of 5 to 7 people, if you don't put caustic chemicals down your drain and it stays healthy, it should only have to get pumped every 5, maybe 7 years. Some people do 3 just to be on the safe side, but if you're adding the right bacteria to it and you're not putting a lot of chemicals down the drain, it can kind of sustain itself for a very, very long period of time. Okay, you guys did your project on sewage treatment plants. You have three-step process. The first one is large bulk items is taken out with screens, what we call a grit tank. Number 2, our aerobic bacteria are going to break down the organic waste, break down a lot of the fecal matter that's still in there, get rid of some of that stuff. And then tertiary, which most places do nowadays, is that they're going to kill the harmful bacteria with chemicals before it's discharged into lakes and rivers. Years ago, they used to not do that, but they started realizing that large amounts of bacteria being released into the water systems could cause pretty large damage or bring on pretty big problems in those water systems as well. Okay, some places will pass through UV light as well to kill some of the bacteria. Okay. Other places use the environment, use plants to detoxify water. And this is a smaller system, but it can be done in urban areas. It's just a matter of space and it being run properly before discharge of that water. All right. That's it. That's the basic overview of it. Hopefully you guys remember a lot of the stuff. Please feel free to ask me questions. And your last quiz for next week should not be that challenging.